All attendees are in listen-only mode.
Hello, and welcome to today's webinar, BIM for Small Projects. This webinar is brought to you by Live Lab Learning, which is a subsidiary of Academic Corp, a wholly owned applied software company created to provide world-class training. This is Mark Mincy, and I'm delighted to be your moderator today. We have done this presentation at a number of cities around our territory and had a very good response. For those who could not make it, we are now sharing this exciting presentation as one of our regular webinars. Throughout our presentation, we encourage you to interact with us by typing in questions and comments using the questions pane. We will be answering questions at the end of the presentation. This webinar is being recorded and will be available to you online at our YouTube channel. If you haven't already, search Live Lab Learning on Facebook and like our page to receive the latest information and special offers. When you visit our website, livelablearning.com, there's a complete schedule of upcoming training. Applied Software is a platinum level Autodesk reseller, which has won many Autodesk awards for excellence. The platinum level is the highest level Autodesk reseller and is achieved by demonstrating an ability to deliver the highest level of solution expertise, service, support, and customer satisfaction. Applied Software is also provides other architectural, engineering, construction, manufacturing, and simulation markets as far as solutions. Please take note of our upcoming events. Another event we've had very good success across our territory is Bim and Beer. Our next Bim and Beer event is in South Florida, is July 23rd. And the event after that is in Boston on July 29th. If these are not in your part of the country, continue to keep a lookout as we are planning on hosting more of these events throughout our territory. Also, I want you to take a note of our upcoming webinars. As I just mentioned, besides Autodesk, we are partnering with leading technology solutions in the AEC market. We have a webinar on Bluebeam on July 9th. Bluebeam provides a powerful PDF editing, markup, and collaboration technology with reliable file creation. It is great for teams using PDF to collaborate. We also have another webinar, Autodesk Design Technology in Higher Education, on July 21st. Now, I'd be remiss if I did not mention we are offering several great promotions on Autodesk software. There are rebates of $1,500 on new software licenses. Autodesk is changing how they sell their licenses. Make sure you get your perpetual licenses before they're gone. If there are any questions on the promotions or the Autodesk license change, please reach out to me. Now, it is my pleasure to introduce our presenter. He is the Director of Applied Software's Architecture and Engineering Technology Group. He has many decades of experience working as an architect and as a Revit instructor. Today, he will leverage his own experience using Revit on small projects to share with you how you too can leverage BIM for small projects. Please join me in welcoming today's speaker, John Ade.
Thank you, Mark. Welcome, everyone. It looks like we have a pretty good crowd, and I'm really pleased to see that. Been working with design technologies almost from the time I graduated college over 30 years ago, and it's been a wonderful ride, and to see all the different changes in the design technologies leading up to BIM and tools like Revit that a lot of people have adopted. So this is an overview of BIM and how it can change how you do your work and how it can apply to smaller projects. Often people resist adopting a new technology less out of whether it will give them the benefits that they seek, and more that out of fear that of the time that it's going to take to implement this kind of technology. We're here to help you, and certainly we can help you with any of the questions you have with your own individual plans to implement this technology and these processes into your workflows. So BIM for small projects, and small projects can be a lot of things to a lot of different people. I will try and address individual cases for how it may apply to you, not knowing exactly everybody in the audience. But the big thing is, why? Why do we want to use BIM? Okay, and what is it? Building information modeling. Most people may have heard of the term BIM. A lot of times they think of BIM as a thing, a model, 3D geometry. They miss the fact that in that is actual action. It is a process. It is building information modeling. So is the geometry, is 3D part of this? Absolutely. But it is not just about the 3D geometry. 3D geometry and the ability to design with 3D elements using digital software has been around for really decades. I did 3D modeling probably in 1987, not long after I was out of college, using something called Intergraph IGDS. And it had the capability then to create 3D geometry, to do visualizations on it, and to even animate it. However, the software back then was very clunky. Not a lot of people had adopted it, and so it was used kind of minimally in the design process, but the software has obviously evolved over time. So what is BIM? Well, if you look at the little bullets on the side, you'll see that a lot of people have misconceptions about it. They kind of associate it with just the 3D geometry. A lot think that, well, now it's all about the data. Maybe it's just the combination of the 3D geometry and data. And no, Revit or, some other application, that's what BIM is. And those are all just parts of the puzzle. So it's not just about 3D geometry or the data associated with it. It's certainly not the tool. The tool is an authoring software. BIM is a process. It's an intelligent model-based process, but it incorporates a lot of information coming from a lot of different sources that can be leveraged and integrated, and sometimes not always represented in the model, but being able to reach out to or share with these different applications for utilizing the information either during design, as part of simulation, during construction to help ensure that the construction process goes smoother, part of commissioning to make sure that the model has all the information needed for managing the facility afterwards, and then for facility maintenance and management. Lots of opportunity with building information modeling. So why BIM again? Early on, when tools such as Revit and other tools out there, not just Revit, came to the forefront and started to be a little bit more intuitive, had more features that allowed designers more capability to actually use 3D without having to learn some sophisticated tools, and so opening it up to a broader audience. People still wanted to know why they would want to do this, why BIM, and the gentleman at HOK came up with his, if you will, graphic representation of how the traditional process is versus the new process. Many of you may have seen this in other presentations or other literature. It's called the McClamey curve, and it was developed by a gentleman at HOK named Patrick McClamey. And it's really just a way of trying to explain it to maybe a leader in your organization or somebody who's a decision maker who may not be actually producing drawings or designs as much as he's administrating and bringing the work in and running the business. And those are the decision makers, and they need to be on board if BIM is going to be a success in your organization, and if you're going to have any chance of implementing it successfully the first time. So you'll see in these two curves here, the blue curve is representing the ability to impact cost changes based on design changes over the duration of the project. And so that ability tends to get narrower or less of an opportunity to make changes without affecting the overall outcome or cost of the project. The problem is that black bell curve is representing a traditional design process where a lot of the information is not collected and put together and represented in the drawings and in the design until later into design development and into construction documentation, where the ability to make those changes becomes reduced. And so with the implementation of building information modeling and tools that actually let you graphically represent through 3D, but also incorporate the information related to the design so that you can make decisions about the design earlier in the process, represented by that bell curve with the yellow fill-in underneath it, means that you can make decisions quicker. You actually have more information with which to base those decisions and therefore have more of an ability to make change early in the design process when it will have the least cost impact on the overall outcome. So BIM for small projects. Interestingly enough, when we have this conversation with people, it's really about scale. Small projects versus large projects. I've worked on projects where I was the project manager, the project architect, and did all the production work myself, and I've also been on projects where I was the project manager managing a team that had a project architect, maybe even a BIM lead, and several designers on it. So I've worked on very large complex projects, but also very small ones. But you're still dealing with a lot of the same factors. You're dealing with a list of criteria by the owner, you're dealing with a budget, you're dealing with a schedule, you're dealing with a lot of demands on coming up with a unique and wonderful design, but keeping it within those parameters. So you take all this information in a traditional workflow, you would be doing more 2D, and some of you or many of you may still be using 2D diagrammatic ways of representing your design using CAD right now and still contemplating them. And then the output is all this information that can then be used for other purposes. So again, for small projects, it's not really about whether you can derive benefits from using these tools. You can. There are what we call the low-hanging fruits of using BIM, building information modeling, and the authoring tools associated with BIM, things like visualizations and being able to derive your set of construction documents and being able to do predictive costing of your project early on by doing scheduling and quantity takeoffs and material takeoffs. And so it's really just a matter of what the size of the project is. A lot of these are still things or outcomes that everybody wants, no matter whether the project type that they do is smaller or larger. It's just about the margin, if you will, or the amount of fee you have to work within that may be preventing you or restricting you from jumping in 100% into the BIM world. So again, small projects versus big projects. Sometimes the demands on a small project or the needs can be larger than a big project. Big project, again, is really in the eye of the person who is doing the work. So don't let the size of the project keep you from deriving benefits from building information modeling. The more important thing is being purposeful and having a plan of how you're going to adopt it. So what are some of the reasons? What are some of the predictable outcomes? What are some of the benefits of using building information modeling? There are tools both within authoring software and also in addition to authoring software that integrates it with programming tools. So tools where you can develop a program and then represent it graphically either in the programming tool or in the authoring tool, and it helps you then keep track of the program, make sure you're meeting the target for that and not exceeding it. A lot of times we'll teach this when we're teaching our clients how to set up basic programming within the authoring tool to track things like area for rooms, both programmatically, what the areas actually are as they design them, and even calculate the difference. All this can be done when all the information is being virtualized in a single model representation of your project. And when we say single model representation, at a small project level, there's more opportunity to put the entire project into a single model. And as we scale things up to a much larger scale or much larger project, sometimes when we say it's a single project, it doesn't mean it's a single model. There may be reasons or benefits to breaking up the project into multiple models and linking them together. But it would still be a smaller set of files, if you will, that represent the design versus having what we call a federated approach in the CAD or 2D world, where you have a single file representing a part of the design, and you have to do a lot of referencing or X-referencing depending on the tool you use, and not all the information is easily collected and edited collectively or together, and certainly not dynamically. BIM authoring tools, because of their very nature, allow you to change something in one place and it's changing it in all the views associated with that project. There's opportunities for conceptual design, so not only doing detailed design, doing construction documentation, but actually doing form editing to get the overall shape of the building, to come up with very complex and organic geometries. Obviously, BIM supports the construction documentation necessary for submitting and constructing a design. BIM supports the ability to make a change and have it represent or update multiple forms of information or ways the information is being visualized throughout the project. It does afford opportunity to enhance the design process because of this ability. Along with building information modeling is tools to help with design options and phasing for renovation, addition, and retrofit work, and do analysis for different aspects of the design. And certainly the visualization is one of those low-hanging fruits, because now you're virtually building your design instead of just drawing it or drafting it. You now have something that you can then visualize through animations, solar studies, and rendering. So we'll get into a little bit more detail on each of these points in the subsequent slides. I do have a few examples of projects at the end just to show some small up to different uses for BIM that are becoming more prevalent in the industry, but some people don't always think of BIM as a need or as an opportunity for. So I want to make sure that you're aware of those, and if you have any questions later, obviously we'll answer those. So again, early in design, we have the ability to do what's called design options, the ability to take what's considered the main model or the overall design of the building and explore iterative design options for a particular aspect of the design. In this case, we have an example of a building that has a very basic roof terrace, but you want to explore different options for different structures or different roofs on top of that terrace. And so within the context of the main model, it's possible to not only show, if you will, the original state where there's nothing designed for that roof terrace other than just an open space, but show different options for how you may cover that space to make it a cooler, more pleasant space for outdoor use when it's warmer weather or even cooler weather, depending on what you're designing for that. And the ability to not only show these in the context of the overall building design, but to also have views set up so that you can present these side by side. So obviously with these design iterations in one model, you're actually setting it up to show this information side by side and even have the ability to do drawings that actually are dimensioned, if you will, bid alternates for these kind of design options. And I've seen a lot of our clients use features like this for bid alternates. And so just a little bit more detail on design options, a different, if you will, application of it, showing different furniture layouts for a particular work area or conference room. And the ability in this dialog, you can see here where it says design options, this is coming out of Revit, but it's showing that I can actually have what's called option sets or groups of options for different parts of the building or different parts of the design. So I'm not restricted to just looking at one aspect, as in the previous slide where I was just looking at roof terrace or roof terrace canopy options, but literally I can have roof options, I can have interior layout options, and even stair options all within the same model. But again, they're looking at aspects of the main design. What I think some people get confused about when it comes to design options is that it is not intended to be used to show a completely or holistically different design one from the other. If that's the case, then it's very much like any other process where you're going to actually create two different models or two completely different sets of drawings to represent that, because they are so much different that you can't just handle that in a set of design options. So this, I have a couple of very short videos in this presentation that just show an example of how this is done in a tool like Revit in the context of a main model, and being able to set up views that show the different options both in plan and in 3D. So I'll go ahead and run this and kind of explain what you're seeing. If I can hit the play button properly. There we go. So in this example, we're just isolating a part of the model where we want to show a change or an option to a particular part of the space. So in this example, you'll see that there's a small room with a desk in it, and then there's a couple of small tables, say in a break area, if you will, off to the side. And we want to do an option where we show not only this, but an option where that room it has a different layout, but also an option where the room doesn't exist at all and there's actually more seating as a recommended alternate. So this is just showing the second option where the room is gone. It's going into the first option where the room exists and actually just doing a different orientation on it, moving the desk around. And then once the desk has been moved within its option, and elements can be added to these options too, and there can be more than just a couple. I've worked with clients who have had as many as 12 sets of options running in a particular project, and as many as 6, 7, sometimes even 8 options for each grouping of options. And here you're seeing both a 3D camera view and a plan view of each of the options. And on the screen we'll just circle the plan area and show you where in the plan and where in the 3D view these options are. And so again, these are two duplicate views just showing the options side by side. These can be printed out, put on a sheet, presented to the client, and then you bring it back and move forward with your design. Another core functionality of your project as a single model is the ability to make changes very rapidly. And when you make changes, it can affect multiple view types, schedules, which are really a data form of a view instead of a graphical view of the project. And one thing to keep in mind too, and I didn't state this early on, is that building information modeling, although it's a process, the tools generally are database driven, meaning they're containing relationships between all these different parts and pieces that are used to represent and also interact with the design, but are also really talking to each other, meaning that a plan may have multiple iterations for different plan types, but it's still the same building geometry. You're just representing or showing different information in each view like we would do through a normal set of construction documents. But the plan information may have a door, and the door may be in a schedule, but it is the same door between the two. So again, the economies of scale here, if you make a change in a plan, it's going to affect a schedule, and vice versa. You can make a change in a schedule and it'll affect a plan, and likewise other associated views. So again, in this example, it's just showing that the same door shown in plan is the door shown in a 3D view, is shown in an elevation, is being scheduled in a schedule. You can make changes to any one of these places and it will update it accordingly in each view. So again, a short video that just shows an example of this and what it looks like. Basically, this is the animation that was where the previous view was derived from, and it's just showing things like the room number, the door number, making a change to the wall to not only move a door but to add a door, and to see those changes showing in all the views at the same time. So again, that particular door is going to be moved, and at some point we're going to change the door itself, maybe even the door number. And then all these changes will be reflected throughout the model wherever it occurs. So again, one door is just being displayed different ways. The way I like to explain this to people is that in this case, Revit has a proprietary database driving it, and so the geometry, if you will, is the data that is populating this database. And these views are reports, and so anytime you make a change to the data, whether it's graphic change or informational change, it's updating it in any of these reports. They just happen to be interactive reports in a BIM authoring tool like Revit, where you're actually interacting through any of these views to incorporate changes. And whenever we go out and evangelize Revit, we actually set this up live as an example just to really reinforce the fact that making a change in the model is actually making it everywhere in the model, or everywhere where you might see it. Very, very powerful tool. Let me see, that's almost over. So again, one of the last changes is just changing what type of door it is. And again, changing that in a schedule and changing it in all the views. So again, a lot of power. The views are a way of interacting with the model geometry, not restricting you. It's just sometimes one view is an easier way to touch and manipulate a piece of geometry or part of your design versus another. Design coordination. Most of the BIM authoring tools inherently have coordination capabilities. You can link in model data for different disciplines and visually inspect it and see where things are running into each other. Some tools have inherently inside of them functions or features that allow you to do interference detection within it. If everything is modeled, let's say in Revit, and you link in a structure model and a mechanical or a plumbing model, you can then do interference detection between the different categories of objects, like structural framing to mechanical ductwork or piping, and so on. And then there's tools outside of that that will take BIM data and allow you to do more sophisticated clash detection analysis. These visualizations are all coming from a product called Navisworks, which many people are familiar with. It's not the only tool out there that does that, but it did kind of set a standard, and it allows you to not only do visualizations, but it allows you to do sequencing, and then it allows you to do what we call clash detection. So our next example is a brief video just showing an example of how a tool like this works, where a clash detection has already been run, and for each clash detection it's listed in a report, and you can go from one clash to the next to visually see where in the model, in the context of the model, the elements are that are part of the clash are located, and be able to address them one to the other, which may require that you're sending a comment about a particular part of the model to everybody who receives this report. And then more specifically, you can also make assignments to people saying, hey, please make this change first, or make this change since you are the owner of this model data. So again, very sophisticated tools. The construction field has been using tools like this for a while. There are now online representations of this tool that allow you to actually do more immediate coordination and review and resolution of clash detections in a more online and, if you will, virtual meeting environment. So with all this data that has been collected and you're starting to represent in a model in using BIM, you now have more opportunities to analyze this information. Many tools are available that allow you to take early conceptual designs and based on their location, based on their orientation to the sun, based on the weather for that location, come up with a baseline predicted, not necessarily exact, but energy consumption for a building. And if you make changes to that geometry, to its orientation, to how it's receiving solar gain, you can do side by side, if you will, iterative options based on different design options to the project to determine what's going to be the best approach for better operation of the building long term. Very basic analysis, taking a model such as this one down here with the, if you will, the compass around it and the graphic representation of the sun, you can physically move the sun around to see how the sun is going to cast shadows across this project to see where you might be getting more solar gain than you really want or need or can tolerate, and make changes and then redo this. But it's an interactive tool, but it can also be animated so that you can capture that and represent that. Other tools allow you for taking the model data into a cloud environment to do further and more refined analysis, both for structure and for carbon neutral design and energy performance. And then there's also tools for doing wind tunnel analysis to make sure that, especially in an urban environment, that you're not getting either too much wind on a particular exposure, or if you make changes, how it may affect the wind around your building and adjacent buildings. So great tools to affect the outcome of the design before you get into construction. Going a little bit back, if you will, into early design, talked a little bit about how we can use the tools for energy analysis. But even before that, we may just be sketching out a very rough idea of what the design is, and there are tools where we can do that and actually take some of this basic geometry into a conceptual design environment where we're massing this geometry, making manipulations to it, and then using that mass information to actually drive the building geometry or the systems that are cladding the building, used for the floor assemblies, for curtain assemblies, and even roof assemblies. All can be driven by a more complex mass form. Now, this one is not very complex, but it can get very, what I call organic, where it has much more free-flowing curvilinear form to it, and it makes it much easier to drive more complex assemblies like this brick wall that we're applying to it, or even just the shape of the footprint of the floor that may change from floor to floor to floor. I used to use the example of the Marriott Marquis Hotel in downtown Atlanta that has a shape and a footprint and an atrium where no two floors, I think, have the same exact shape. And that's a lot of very detailed information. If they had had a tool like this to be able to do their conceptual form and then have that define the footprints, and as they make changes, it automatically update them, I think they would have been very happy to have had this some 25, 30 years ago when they built that building, designed and built that building. Another great opportunity is visualization. Since you have all this 3D information, you have representations of how different assemblies go together and be able to represent the different materials. You can now visualize them, present them to your client, and in certain environments, this is an example of Showcase in the upper image, being able to put it into more of a dynamic presentation environment where it's doing real-time rendering, and you have the ability to pick surfaces, swap out materials on the fly to see how different materials will look interactively with your client, and even set up design scenarios or combinations of materials and be able to quickly go through different combinations with your client in an environment like this. This is becoming much more popular. It was used very much in manufacturing and has now been made available for, gosh, past 3 or 4 years now for the architecture, the AEC community. Further visualizations, obviously we have the ability to do still renderings. These renderings can be done in products, and there's also cloud solutions where you can take the setup for the rendering, the model information, the materials, the actual view orientation, and publish that to the cloud and offload, if you will, that burden of doing the rendering on a machine so that it's not taking up some piece of technology when you need it to continue working on the project, but have it do the rendering out in the cloud and return a finished, polished rendering that may have taken hours on your machine, may have only taken 10 minutes in the cloud because of the power of multiple computers there, and then return it to you in an email and say, hey, your rendering's ready. You also have the ability in the cloud to do different types of visualization. This one being an illuminance study where it's showing you where light is hitting different surfaces and bouncing off of them and illuminating different parts of the model, and using color to show where it may be getting too much direct sun and other areas where it's getting too little. And then there's different rendering engines available to you in products. Again, I'll use Revit as the example, but you have now in the latest release of Revit, not only do you have the mental ray, but you also have the V-Ray rendering engine. I think I've got that right. Probably misspoken. And then even just standard, what we call views or view styles, you can have a rendered visual style that is not quite a full rendered view, but it allows you to see the materials and see entourage like trees without having to do a full rendering. So the tools are getting much more sophisticated. They are supporting the workflows for not only large firms, but huge benefits for smaller firms and smaller projects. And I'm not trying to equate small projects with small firms, because I know a lot of small firms that do very large projects. But again, small firms either tend to be first adopters or tend to wait until everybody else has and then follow. So this is just a little summary of some of the things that we've seen. You know, why BIM? One of the big things is it's a way of containing not only the information for a project in a single file, but because of the dynamic nature of databases and the relationships between the different parts, there's a stronger benefit of being able to incorporate changes or create information without having to do duplication of effort, and basically maturing of the information from conceptual design all the way through to construction, all using a single model entity. So again, we talked a little bit about one model, many views, single element change, updating in all views. The inherent ability to do coordination both within the model but also with tools that will identify clashes so that you have a more predictive outcome between design and between the actual installed product. We have the ability to take early sketch tools for those who may never work in a more sophisticated BIM authoring tool such as Revit, being able to take their natural ability to sketch and bring that into more of a conceptual design environment and integrate the two and start the project off with rich information that can then be driven by more complex geometry, and then bring that into presentation tools for presenting to the client or internally to make decisions about the design. And then the ability to do iterative design, different options for different aspects of your project within the context of the overall design. And then energy analysis, wind analysis, whoops, got a little ahead of myself, even structural analysis. There's a lot of different opportunities. There's also simulation tools for even showing the flow of air conditioning within a space. Seen that used for data centers and for atriums, for smoke exhaust. So there are tools now, once we have this information that we've used for early design, not only does it provide us rich information for making better designs early in the project, but we can use it for more sophisticated forms of analysis, either by ourselves, or if there's somebody else who can do that for us, they would probably want that model information. So, talked a little bit about Revit here and there. That is kind of the flagship product for Autodesk. There are other tools that come with different suites of applications that address people's need for still using AutoCAD tools, but AutoCAD-based tools that do create model information that can be leveraged in a blended environment, and using tools like Navisworks to do coordination and clash detection. Huge visualization opportunities both within the products, but also using other products like 3ds Max for high-end visualization, showcase for, if you will, in situ real-time rendering and being able to look at different material options. Then, of course, Revit itself has rendering capabilities both inside of it and the ability to push rendering out to the cloud. Tools for doing coordination and clash detection, and of course the cloud surfaces that I've been touching on here and there for analysis, for rendering, even for sharing and collaboration. And then even for construction, there are a suite of cloud-based applications for coordinating construction efforts in the field and doing further coordination. And before we take any questions, I just wanted to just show some brief examples of smaller type projects that we're starting to see more clients start to come to us and say, you know, how do we do this? We feel like we're missing out. So residential or high-end residential, we've had a lot of requests for recently. Interior design firms are now coming to us and asking a lot of questions about how do we incorporate that. It has been used in commercial interior design for years by many of the larger interior design companies, but it's certainly a huge opportunity for the smaller designer or the smaller company to start leveraging these tools. And you can do what's called a blended approach. Much of interior design is still represented as CAD data. And so if you're doing a design or a renovation of a space, you may have that to start with, but you can blend both 2D data and 3D data using BIM. And then obviously interior law firm project, multifamily, so not only single family, but multifamily, has been making strides in using Revit and BIM processes for that particular project type. And just a couple more projects, both big and small, that were done in BIM. So I'm going to go back up to our question slide. Didn't want to forget showing you these. I kind of put them at the end, but just want to see if there are any questions, and I'll have Mark kind of feed them to me if there are any out there.
Sure. And first of all, John, thank you for that presentation. You did a great job. We do have several questions, but for those who want to ask questions, again, you can go onto the panel on your right-hand side and ask questions by typing them in there. Then we will read them out for John to answer. So we do have a couple questions, but again, we always appreciate any more who have questions. So the first question comes from Jack. And he asked, can you import Revit models to Civil 3D or vice versa, Civil 3D models to Revit?
Wow, that's actually a really great question. There is actually a workflow going both directions, and there's also an intermediary application. I hate to say, I'm not sure if I'm using the word right, but let me answer the question first and then talk about a little bit about Infraworks. So yes, you can't link a Revit model directly into Civil 3D, but you can export the model into what's called an Autodesk format or ADSK format that can be brought into Civil 3D. Civil 3D data, if it's three-dimensional, say, contour information representing the topographic aspect of the site, that can be brought into Revit, and you can, as an Autocad 3D file or as a points file, so that you can then quickly generate the site topographic information. What we're seeing becoming very popular very quickly with civil engineers, and even as much with architectural designers who do a lot of site planning feasibility studies, is using a product called Infraworks. Infraworks will allow you to do more preliminary and conceptual design, bringing in real-world geometry, even geometry from Civil 3D, and it will directly allow you to link a Revit model or models into it to represent, say, the building on a site or even a campus of buildings on a site, and allows you to add model roads and contours and bridges and all sorts of aspects. So as much as you can't link Revit directly into Civil 3D, both those products feed into Infraworks and then can feed information back out to both of those products. So hopefully that gives you a bigger answer than you were looking for.
So Jack, if you need more information, that either you can contact us or you can write another question. We'll gladly answer that to John. Jack also has another question he asked a little later on. How does the lighting model take into account outdoor landscape?
Are we just talking about a rendering or an illuminance rendering?
I'll have to wait for Jack to clarify that, but it's an illuminance rendering. Okay.
I'm not sure if I have the answer for that. It's my understanding that the illuminance analysis is still using the rendering engine, and rendering, for anybody who's done 3D work or any type of rendering, is all dependent on light. And so because of that, they are able to expand on the rendering engine to actually create these illuminance views. So it's my understanding that if you have entourage that reasonably represents, say, a tree outside a window, and your illuminance is taking into effect, obviously, sunlight coming into the space, it should adequately represent, say, any shade or shadow that the tree would cast. Now, I'm making a little bit of an assumption here, but based on what I know of the tools, that's what it should do. I would have to verify that.
Thank you. We have another question from Edward. And again, I can just encourage anybody, if you have any questions, feel free to write them in the panel pane on the right-hand side. So Edward has a question. What is your recommended approach to transition from AutoCAD architecture to Revit?
Ooh, another good question. We do that a lot with our clients, probably more from AutoCAD, or what I call AutoCAD Architecture Lite, to Revit. And if you're using AutoCAD architecture the way it was intended to be, meaning you're really setting up a project using Project Browser and using Project Navigator, and you really are trying to kind of do a 3D project in AutoCAD architecture, it'll be a little bit easier transition because you already know maybe some of the limitations, but also the strengths of creating more of a model approach to a design. If you're only using AutoCAD architecture in what I call the light mode, where you're using the basic, walls, doors, windows, spaces, maybe a few other objects, ceilings, but you're not really using Browser Navigator to do your project, then I think instead of trying to use more of AutoCAD architecture, you're kind of ripe for going to Revit architecture, because it really integrates all that AutoCAD architecture is trying to do, and does quite well, by the way. I mean, we represent all these products. We're not trying to tell you should, but if you're not using AutoCAD architecture all the way, I would say Revit's a natural. And the first step in that is we like to have a conversation with you just to know, what kind of work you do, how you're currently doing it, how you're currently using AutoCAD architecture, and make sure we understand what your goals are and how your current workflows are, so that we can then agree together on what would be a good approach to implementing Revit, starting with what would be a good project, what kind of training you would need, what kind of standards development you may need. So it's kind of a discovery, coming up with a plan that may have multiple parts, which probably would start with training and maybe some standards development, identifying a project, and then helping you answer questions as you do your first project or two. So that's kind of our approach to an implementation. Hopefully that answers.
Edward, that was a great question. Edward, that was a great question, so thank you for asking that. We have another good question from Brian. He asks, how does an MEP engineering consultant coordinate with the architectural model? Is a single model shipped back and forth, or are there multiple models that get linked together into a master model for coordination?
Awesome question. Really well asked too, and we kind of alluded to it a little bit, but you're right, we didn't speak specifically to it. No, you wouldn't pass back and forth a single model. However, with an advance in the technology, it is possible to do that without passing it back and forth through something called A360 Collaboration for Revit. Typically, we would not recommend having multiple disciplines in a single model. So what you would do if you were, say, the MEP engineer, is you would get the architectural model, a copy of it, you would link that into a model that you start that probably has nothing in it yet because you don't have the architecture for context, but you would link in the architecture model, and then you would start to do your design within the context of the architecture model. And then at some point between you and the architect, maybe the structural engineer and the contractor, you may bring all the models together and collectively do a coordination review to see where things are intersecting, and obviously make changes to the design as needed. Or that can be done just between you and the architect. You can do smaller coordination meetings. But yeah, you would typically have your own model, and if it's a really big project, I know we're talking about small projects in this presentation, it might even be a separate mechanical, separate electrical, separate plumbing, separate fire protection model that you may be responsible for, and then link them all together when you want to do coordination, or any time to do coordination. So it's a big question, and it has a basic answer of you would typically not do everything in one model unless you maybe were a firm where you had all disciplines together and it wasn't too big of a model where you could contain everything together and you wouldn't have to pass it back and forth. But in a traditional relationship, you would share a copy of the architecture with consultants, and then they would use that to base their design on.
So Brian, thank you for that question. We have another question here from Joe. How much of what was shown is included in subscription, and how much is only available at an additional cost?
Let me go back a slide because that'll help, I think, a little bit. And I think you and I can both answer that question, but I'll take a quick stab at it. So it really depends on what product or products you have first. So let's say if we're just talking about Revit. So Revit has a lot of capability built into it, and with that subscription gives you a certain amount of access to some cloud tools. And then once you've exhausted, say, some of that access, you can purchase more access to those cloud tools. If you only have Revit, you can do rendering, and you can do it in the product, unless you get Revit LT, which does not have rendering in the product. It's only cloud-based rendering. But with subscription, you get access to some of the analysis tools in the cloud for whole building energy analysis. Other tools you can buy individually, but generally what people do is they'll buy a suite of applications called Building Design Suite. And then you get things at the premium level, which includes Revit. You get all the Autocad flavors. You get 3ds, Max Design, Showcase. You get Navisworks Simulate, and of course Revit. At an ultimate level, then you get a few more tools, which include something called Navisworks Manage, which has the high-powered clash detection tool, and Inventor, and I'm missing something. There's another application up there at the ultimate level. So it's really a combination of whether you have a product individually, a suite. Subscription then gives you some access to some cloud tools. Others are by subscription only. So on this page, I'm showing what are called some of the BIM 360 tools, like Field and Glue. Those are subscription only. So you don't get those unless you buy a separate subscription to them. Mark, am I explaining it well? Can you fill in any blanks?
Well, it is an involved answer. So that, again, a lot of what you showed today depends on what products you have, just like you stated. And then adding subscription does add a number of benefits. Joe, if there's one in particular you're looking at, or several that you're in particular, we surely can reach out to you and answer that question. Feel free to write that in as well. Again, we're glad to answer that question if we haven't already. Again, we have the emails that started at the beginning. We'll also have them at the end as far as how to contact us. So again, if we don't answer any of your questions well enough, feel free to reach out to us, and we'll answer them best we can. That was the last question that we have. John, just want to make sure, can we somehow display our contact information? Do you have a slide that shows that, just in case anybody needs to get a hold of us?
I can go right up to the top, I think. Let's see if I can try this. Yep, that didn't work. I was going to try and do it with a keystroke, and it didn't work. Let me just go up to the top here.
So any other questions, feel free to write them in. We got just a few minutes left. Again, we do appreciate all your time attending this session today. Hopefully it was informative for you. Again, we couldn't cover everything, but that's where we are glad to answer any questions that you have. And you now see our contact information for both myself and John. Feel free to write us, and we're glad to answer that. I did get another question. Edward wrote another question here before we end. For a small studio, what support does Applied Software offer to assist with software implementation issues, such as remote login or personal studio visit? And again, I thank you for your great presentation.
Well, I think that would start with a conversation. If you purchase software from us, we help with making sure it's installed and licensed properly for you. But we have a variety of services ranging from our live lab learning training, which are open classes, to just coming in and having a conversation with you to determine, what you want to achieve, and talking to you about how we think you can achieve it, and what would be involved in doing that. So it's all individualized, but obviously some elements are things that people can pick and choose to do with us, such as the live lab learning training, which is our standard training, but it's all led by instructors such as myself live, so it's not video recordings, it's interactive.
So Edward, if we didn't answer that question, or if we can answer that question in greater detail, please reach out to us. Glad to discuss your personal situation to come up with a solution that fits your needs. But that is the last question that we have. So again, thank you for joining us today. We hope that you found this webinar informative and a help to your business. We look forward to joining you on our next webinar, again, the Blue Beam one on July 9th. You have a great day.